Okay, this is Mr. Cox again, coming to you from my makeshift science lab here, aka my basement bathroom, where we're going to do a little experiment regarding density. All right, so here's a foil ball, like I asked you guys to make and try earlier in the week during our snow on Monday. All right, I've balled it up. I'm going to throw it into my bowl of water, aka my sink, and notice that it floats. All right. Now we're going to take some calculations here on this piece of foil using our tools. So I just put that on my triple beam balance there, like we learned about earlier. All right, we're going to measure the mass of it. Ooh, it's very light. So let me go back here. All right, getting pretty close there. Not 100% yet. All right, we're going to be talking about density and mass and volume here, so we're going to use both of these tools. There we go, that's pretty close. So our foil is about 2 and 8 tenths of a gram, so 2.8, 2.8 grams. All right. Now, if I wanted to measure volume, it gets a little tricky, right? Because normally with volume, you would measure length, width, and height, and you would multiply. Well, we can't do that with something that's not a cube or a rectangle, right? So what we're gonna do is I'm gonna pour some water into our graduated cylinder. All right, and I'll show you what happens here. I'm gonna go up to about 40, so it's easy for you guys to see. Right on 40. Okay. Now, what's going to happen is I'm going to throw this in here, and hopefully the water level is going to go up a little bit. Right now, it's right on 40. There you can see it wiggling. Okay. Now, it was at 40, and now it's at 40. Let's see, 41, 2, 3. So we went from 40 milliliters to 43, and I didn't add any water. So that means that the volume, how much space that foil ball takes up, must be 43. Okay, so I'm sorry, it must be 3. It was the volume in the graduated cylinder was already 40, and because it increased to 43, the difference between 43 and 40 has to be the volume of just the foil ball. Okay, so I'm going to pour that out. So we had 2 and 8 tenths of a gram, and we had 3 milliliters. All right, so now I'm going to take this foil ball and I'm going to squish it more. Now, what I want you to think about while I'm squishing it more is, what am I changing? Am I changing the mass? I'm going to use my pliers because my fingers aren't really strong enough to do it the right way. Am I changing mass? Am I changing volume? Am I changing none of those? Am I changing both of those? All right, remember we're focused on density today. And density is a comparison of those two things, volume to mass. All right, so I just squished it like a pancake. Let's see what happens now. Oh, it no longer floats. See, my hand is underwater there, and that's hard to see on the camera, so it sunk. Okay, dry it off here. Now, if the mass stayed the same, then our balance should still work, right? It's off right now because I left that 2 and 8 tenths of an ounce on there. So let me put this back on here, and let's see what happens. All right, let's see. So that doesn't agree. So let's come back just a little bit. There we go, now we're moving. That's about right, maybe a little more. There we go. Okay, so our new mass now is 0 and, let's see, that middle line in between there is 5, right there. So 5, 6, 7, 8. Maybe between 8 and 9/10 of a gram. So our mass went down quite a bit there, comparatively speaking to what it was before. All right, same thing with our graduated cylinder. Let's check our new volume here. I'm gonna try to fill this back up to, whoa, got a little crazy on you guys there, sorry. Try to get to a nice even number to work, there we go. So it's right at 70. You guys see that 70 on there. Okay, let me drop it in. And it sunk to the bottom. Ooh, there it goes. All right, now we were at 70. Wow, we went up 1 milliliter. It looks like right at 71. Okay. So we had a change in both our mass and our volume. And now what we're gonna do is some calculations to look at how that changes our density and perhaps why the foil floated the first time and sunk the second time.